Hello, and what we're going to talk about today are the three types of volcanic cones. Understand the volcanic cone tends to be cone-shaped, tends to have a crater at the top, tends to be made out of molten rock or solid ash or pyroclastics, which fire rock, stuff that comes shooting out of the volcano and landing with a poof, poof. So we're talking about these type of cones. Now these cones actually have a couple of considerations we have to talk about. Now I had my kids dissect, I think, a University of Columbia website that actually talks about volcanic cones, and they were going to learn things like viscosity, resistance to flow. They were going to talk about silica content, and then hopefully learn the three types of cones. And then I'm going to show this video to them, I hope, if it turns out the way it can. It's a little big. So the first consideration we have to think about is whether the molten rock that comes out of here, remember it's magma inside, called lava outside. If we're molten rock, we do have things called pyroclasts, fire rock, remember clastic for sedimentary rock. We also have things that are called volatiles. These are gases that come out. So we can get solids, liquids, and gases, the three forms of matter on the planet coming out at the volcano at any one time. But basically, it's whether we're talking about the chemical compound or chemical makeup of the molten rock, and the two big choices, felsic. Felsic rock tends to be silica rich. Let's say, and that silica is actually SiO2, SiO3, or SiO4, comes in a couple of different flavors. But silica rich magma tends to be the thickest kind. So it tends to be thicker, and I'm actually going to say thickerest, because it is the thickerest form of molten rock. It's the thickest, which basically means it's the most viscous. Viscous means resistance to flow. If you had an inclined piece of wood and you put water that could flow down, honey that could flow down, and I don't know, something even thicker, concrete that could flow down, you tend to find out that the slowest one, more viscous, because it resists the flow. So this is the most viscous of any of the types. So you got the thickest magma, and because it's the thickest magma, it's actually able to trap volatiles. It's able to trap gases. Gases like water vapor, gases like carbon dioxide, carbon monoxide, any type of gas that could be trapped inside the earth. Okay, the second type we have is Mafic. I'm going to change color. This stuff tends to be silica poor. Where this up here may be 60 to 70%, this may only be 40 to 50%. So we're not talking very much difference, because silica, oxygen and silicon make up most of the Earth's crust. So whether you are, probably should keep that same color, whether you are continental rock or crust, or if you are oceanic rock or crust, you are made out of mostly silicon and oxygen. Oxygen and silica. Oxygen makes up about 50% of every rock you can see. Okay, one more thing. This stuff tends to be less dense. This is 2.7 grams per cubic centimeter. And Mafic tends to be something about 3 grams per cubic centimeter, which is why this makes up continental rock and this makes up oceanic rock. Okay, this tends to be thin or more runny than this. Because of that, it doesn't trap volatiles, so it's actually allows gas to escape easily. And it tends to actually make relatively quiet eruptions. This one up here tends to make very violent eruptions. And then we have the third type, which different color, right? Intermediate, where this stuff is like the rhyolite, the pumice, the granite, the obsidian of the molten rocks, both intrusive and extrusive. This is the basalt, the gabbro, the scoria type of rock, and this is more like diorite, andesite, things that actually have characteristics of both. So, density, somewhere in the middle, say 2.8 grams per cubic centimeter. Tends to be average silica. It tends to be average viscosity. It tends to be average eruptions, and this tends to make more, where this is continental rock, this is oceanic rock, this is more like what you'd find at the coast. So this is more coastal rock. And in terms of eruptability, probably the most dangerous of all the eruptions. Because we actually build up some of the thickness of this, we build up some of the water content in this, which tends to be the volatiles, which tends to be trapped by the thicker molten rock that tends to actually make this eruption the most violent. Okay, so let's go down and let's talk about the 3 types of volcanic cones. First one I'm going to talk about is what is called, and I'll draw that a little larger. First one, this is going to be a shield cone. Okay, shield cones tend to be found, well, actually all over continental as well as ocean, but I tend to think of these things more in terms of oceans. They tend to actually have quiet eruptions. They tend to have that runny lava. They tend to have an incredibly wide base because this lava can run so far. They tend to have a very gentle slope. Examples of these are like the Hawaiian Islands. Is there another A in there? Hawaiian Islands. You can also find these things in other places. Iceland. You can find them someplace on continents too, but they also, this runny lava tends to be in what are called fissure flows. Fissure actually means that the ground opens up and this stuff actually starts flowing out. Let me draw this one for you. Okay, we'll have green ground. Here's where the conduit is going to form. It's where the molten rock comes out. We have down here magma chamber, which I've talked about before. This magma tends to be very poor in silica, like 50%. Tends to be very non-viscous, so the lava runs. And when it comes up, it doesn't pile up here at the opening. What it does is it flows out as far as it possibly can. Does that in both directions. This would be your crater. Next eruption comes out, flows farther, and this eruption flows farther, and it just keeps doing that. It gets a little bit more steep each time, so this stuff runs a little faster, runs a little farther, and what it ends up doing is it gives you a relatively nice, wide, nice, gently sloped volcano, the Hawaiian Islands. So if you can imagine the island of Hawaii, looks something like this. Sticks up out of the ocean. Most of it, by far, most of it is in underneath the water. The island of Hawaii actually has Mauna Loa and Kilauea. Kilauea is a very active volcano. Mauna Loa would be like right here. Kilauea is like right here and actually being fed by this, but it actually is moving away. And there's a newer volcano that actually is coming up called Loihi. Loihi is about 3 miles tall, but it's in about 5 miles of water, so it still has a little bit more to go. 50 million, 75 million years in the future, this will be the next Hawaiian island, and we'll talk about hot spots later on. Okay, number 2. Number 2 is called a cinder. Don't like the thickness of that. Called the cinder cone. It's made out of felsic, thick, sticky, and when this volcano actually starts forming, it does a lot different than what that shield cone does. This is the smallest type of volcano. This is the smallest cone. It is the steepest cone. It is the narrowest cone. It tends to have explosive eruptions, but usually with pyroclasts, with rock. Examples of this one, again in Iceland. There's a really beautiful one called Sunset Crater in Arizona. You can Google that. Beautiful crater. Let me show you what this one looks like. Okay, here's the ground. There's where the conduit is. And basically what we have is we have this magma chamber down here, but this tends to be viscous, really thick stuff. And when it comes shooting out, it comes shooting out as a pyroclastic flow. And it lands on the ground. And more of them come out. And more of them come out. There's actually a story of in Paracutan, which is in Mexico, of a corn farmer who was actually plowing his field. Donkey was going up and down, and the field had a lot of cracks on it. It was springtime before all the rains came, plowing the field, getting ready for corn. And the farmer noticed a small crack in the ground and these little rocks pouring out. So he plowed over it. Went over and plowed some more field, looked back, and it had opened up again. He plowed over it a few times. Finally called it a day, went back inside, woke up the next morning, and he had about a 15-foot pile of rock and still coming out in his field. And at that point he gave up trying to fix these things, and what he did is he went to town. They called some volcanologists out, and it's the only volcano that we've actually seen where man has actually seen one day there was no volcano and the next day there was. And also in terms of extinction, we think that volcano will probably never erupt again. There are a lot of these volcanoes in this part of Mexico, so we think it'll probably never happen. So what basically happens with this volcano is we get a pile of, that's not a pen, we get a pile of material that builds up with small little pyroclastic flows. And again, it's going to be all the way around, but it's going to make that pyroclastic flows. Next one comes out. We just get another layer of pyroclastic flows. Pyroclast like cinders, which are pebble size, which is why these guys are called cinder cones. They can be bombs, larger things that come out. And you think about a bomb, you can imagine one of these bombs getting poured out of this thing, coming down and hitting something. It can cause a lot of damage. But it can also be ash, but it tends to be really thick, sticky stuff, so it doesn't really flow. It just kind of builds up a pile. So again, these are the steepest of the cones. They are actually the narrowest of the cones, and they still have a crater that's out there. They also tend to be the smallest of all the cones, but that's a cinder cone. Okay, the last one we're going to talk about, and in my opinion, the best one. Give me 1 second. I need to enlarge this canvas. We're going to make it 2500. Can't just hit OK. And then I'm going to go in and get black, and I'm going to go ahead and color that. And then I'm going to go back to layer 1, and I'm going to center this puppy again, and then go down and try to use the mouse, and this bamboo pen can be a pain. Okay, the last one is what is called a composite cone. Composite means it's actually two volcanoes in one. A lot of people will call this a stratovolcano too. This is our third type. This is number 3. Don't know if I numbered 2. This was our number 2, because if I recall correctly, that was our number 1. So our number 3 volcano tends to be a little bit of both of these. They tend to be, let me make sure I wrote these up there. Yes. This tends to be medium size. That doesn't look like purple. Medium size, medium base, medium slope. Also tends to be, because it's made out of both types of molten rock, tends to be incredibly violent in terms of eruption. And I'm trying to figure out what happened. I don't know what happened to the rest of my notes. Okay, so this tends to be the most violent. It tends to be very water rich, which are the volatiles. Tends to be very thick at times, thin at others. So it actually builds up a lot of the pressure and has a trouble releasing it. But let me show you what this one looks like. So if I actually drew this cone, there's the conduit again. It's going to be a little bit of this volcano, because again these are at the coast, and it's going to be a little bit of that volcano. So I'm going to be changing color greatly. I'm going to start with red. So the first thing we get is we get a cinder type flow. And with that cinder flow, we get cinders in here. Thick, sticky, pyroclastic type material. Then we move over to silica pore flow. Has a little bit more slope, so it can travel a little farther. May not be as thick at the top either, but it travels farther. And then we can flip back to another one of these. So we get another pyroclastic type cinder cone buildup, viscous felsic. And then I'm just going to go ahead and alternate it. It doesn't have to alternate. You could actually get 6 of these basaltic flows, or the mafic flows, and then you could get 12 felsic or the cinder type flows. But I'm just going to alter it. The angle of repose, which is the angle that it can actually support its own weight, these loose materials, is changing. You notice it was horizontal, now it's actually got a slope. So these can actually tend to go down a little farther with this growth. And I'll put one more of each. And again, that's probably thinner. Goes out. And another one of these. And lastly, another one of those. Great example of this one is a volcano that's called Mount St. Helens. Also, probably the prettiest one, Fuji in Japan. These guys tend to be medium based. They tend to be medium slope, not quite as steep as the cinder cone, even though it's in there, and not quite as gently sloped as the shield cone, but it's in there. But these are basically the 3 types of volcanic cones. Okay, thank you much for listening. I appreciate it. Bye-bye.